And Bob, you know how this goes. There's a wave of people joining, so
Yeah, I'm watching my toolbar fill up over here. So, well, hello everybody. 9 o'clock Mountain Time, 10 o'clock Central. Uh, Welcome to the ALP program update for 2025. We're going to give it here just a couple minutes or 1 or 2 minutes to for everybody to get logged in here. It's been a busy week for me already. I did the commodity classics on Monday and Tuesday and was in Reno for the Western meetings on Wednesday. So I'm glad to be back in the office and not on airplanes. So
I still got some people coming on, so let's hang out another minute here, Bob.
sure. And for those of you, probably a few of you who attended the commodity classic in Denver this week, wow, what a show! Drones, mega drones were the title of the show in terms of vendors showing off these large drones. In fact, Corey and I were just talking about some semi-truck platforms now that can handle 4 drones at a time to refill them with product. So it was quite impressive. The other thing nice about the Commodity Classic, besides getting to see old friends and stuff, is man, talk about the great food that they serve there, right? John Deere must have spent a fortune on catering that thing. So, okay.
All right, guys, welcome to this is actually the February Alta webinar, though we're doing it in March, where we're going to hear from Dr. Bob Miller about an ALP update. Just some housekeeping. Dr. Miller will present for a short time. As he presents, if you want to put questions in the chat, we'll make sure all the questions get answered after the conversation. With that, Dr. Miller, I'll hand it off to you.
Thank you very much, Corey. Again, welcome to the ALP program 2025 update. Myself, Chris Sirica, and it says Taylor. I'm sorry, search and replace didn't replace her first name with Cassidy, but that's short notice. I didn't get a chance to fix that. Okay, let's see. Here we go. How come we're not advancing? There we go. So, as you all probably recognize, the ALP program, we're celebrating our 20th anniversary here of providing proficiency testing services for labs that provide soil and plant and water analysis. You know, it's quite a database we've generated in this last 20 years. We've ran 275 soils from across the US and Canada, 192 plants, 165 water proficiency samples. And you know, I say it's quite a database because every sample is run in triplicate. We're running about 122 labs in the program. I looked at the database actually about 2 weeks ago. We were at 1.7 million analyses just in our soil proficiency database. So it's besides being a proficiency program, it's really unique that we have this database that we can look at different soil parameters and relationships. Now, my talk today is going to focus a little bit on the proficiency soil samples, how we process PT samples. We'll talk about proficiency statistics. It's been kind of a hot topic within the Alta group over the last 6 weeks. And then PT sample updates, and I'll give you a brief up on the carbon program. So when we go out to collect soils for the ALP program, I realized back in about 2010, you know, we really needed to hit the country on a distribution across the different parts of the US and Canada. And I've separated out in this figure here, the West, the North Central, the Northeast, and the Southeast. And this is all based on what the regional soil work groups that serve those different parts of the country. And so as you can see there, upper North Central region, we've pulled almost 100 soils to run through this program since 2006. And obviously the West has been pretty dominant, the Northeast much less so, and then the South there, you can see we've pulled soils. And so the real point I'm trying to make here is we try every cycle 3 times a year to pull a soil out of each one of these regions plus Canada to put it through the PT program so that every cycle you will see a soil from your part of the country. So now, how do we select our soils? Well, obviously we have our first designation where we're pulling soils by the regions. We have 6 primary soil test parameters that we select soils on. That's pH, EC, phosphorus, K, organic matter, and texture. So we look at what we've ran the last few cycles, and then we will go back to that region and we'll say, hey, let's pull a soil with a different pH from that region, or we'll pull a soil with a less phosphorus, or et cetera, et cetera. You know, when we look at the soil triangle, 12 different categories for soil texture, we've ran 11 of them. The only one we have not ran is the pure silt category. And then when we look at pH, P, and K, we have what we call, you know, maximum concentration limits that we use. So for pH, we pretty much focus on the 4 to 9 based on a 1-to-1 water extraction. For Bray, it's 1 to 160. And we've put a cap on that because as far as I'm concerned, my own personal opinion, once it gets a phosphorus of 200 or more, it really doesn't matter. You're really testing your lab's ability to do a dilution for the instrumentation. And the same applies to K. We put an upper limit on K at 700 parts per million. Now, we just looked at our inventory. We've actually moved to a new warehouse that's much larger to house all our future soils. And right now we have 96 soils in our warehouse for future use. Quite the warehouse it takes to hold all this. And FYI, that's 2,790 buckets of soil that we have in the warehouse. It's all been air dried, but not all of it's been processed for the program. And there at the right, you see the screen. You see screenshots of where we've been over the last, 15 years: Quebec, Maine, California, Kentucky, where we've collected soils. Now, when we process, well, this is interesting. There we go. When we process our soils, when we bring them in, we just do air drying. And because we live in Colorado and because we have low humidity, pretty much 600 pounds of soil going on a tarp, 2 hours, middle of the day, and it gets dry. It's not perfectly dry. I mean, it probably has 3 to 5% moisture, but it's air dry. And we use this Fritsch jaw crusher here. You see there at the right. We purchased this from Germany back in 2016. It can process pretty much a 5-gallon pail of soil an hour. We have the option there to adjust the size that we want to pass through the crusher. And it really works well. When we get done doing our initial crush on the soil, well, we're going to remove the coarse organic matter fragments. These are fragments more than 0.2 millimeters in diameter or length. And we remove these because they're really a problem. They will pass through the screen in one direction, even though they get caught on the top of the screen. And down there at the lower right, you can see there, this is off our power sieve we have. And you can see that we have this cluster of organic material. My son Colin actually figured out a way how we can adjust the counterweights on this power sieve to actually segregate the organic matter from the solid phase, at least the coarse material there. And it really works well. We power sieve these soils through a 28 mesh screen. They go into our V-shell blender for blending. We usually reduce the moisture at that point to less than 3.5% before we put it in the V-shell blender, and we blend it for 30 minutes. So when we get done blending, these soils are packaged and we do a homogeneity verification after they've been packaged, and we use 7 parameters. So we're going to look at these 7 parameters and focus probably on nitrate, EC, and organic matter, because those particular tests are the ones when we notice if we have a problem, we have to reblend it. And I can tell you this, of 275 soils we've ran, only once have we found that we failed our homogeneity test. So, we try to look for RSDs less than 1 or 2% to satisfy these 7 constituents. Now, we're all based on the methodologies that we use for these soil testing, and we have these reference documents there listed at the right, all based on the regional work groups, what they have published, such as the North Central region. And that totals out to 112 soil test parameter methods we have. And in the case of pH, we have 6 methods. In the case of phosphorus, we're at 10 and K at 6. So the bottom line is that depending on what part of the country, depending on what methodology the lab is running, we have many options there for the proficiency test procedures to look at the different methods. And that QR code you see there on the screen, and this will be up online for you to look at, This lists all the soil methods that we have in the current ALP program and their corresponding Modus version 2 codes for data processing. Now, as I said earlier, one of the things that's been a hot topic for at least within certain circles within the labs and the Alta group is the discussion of how does ALP do statistics? As many of you know, I ran the NAPT program from 1998 through 2005. And when I got to the end of that, I wasn't really satisfied with how we were doing statistics. At that time, we were using a 95% confidence interval based on the MAD. The MAD is the median absolute deviations of the median. We have to use this method because these data sets coming out of all these proficiency samples, all these soil parameters, all are non-normally distributed. In other words, they have a skewed tail to them. And generally speaking, pH, pK, organic matter, all tend to skew towards the right. In other words, you get a value higher than 1. Ideally, you want a skewness value of 0, but rarely do we see that in our data sets. So when I joined up with Collaborative Testing Services back in 2005, we looked at different methods that Collaborative Testing Services is using in their other proficiency programs. And so I'm going to kind of go through this real briefly. And so when you look at our data sets and our reports, you have the lab mean, the average of your lab reported results. Now, each lab is to perform each test in triplicate. And you say, well, Bob, the old program, you only used it once. Well, I realized after many conversations that most labs are running these PT samples more than once. I can tell you one lab I was in, they ran it 3 times a day for a week. So to capture that internal lab precision, we elected to collect 3 results. Ideally, we would like to say the samples were ran on 3 consecutive days or 3 separate days. When we compile the stats, we compute the grand median, which is all the median of all the lab results that we have. From that, we establish what's the median absolute deviation. You can see the equation there is you take the absolute value of the difference of the individual lab mean from that of the grand median there. Then we establish from that the 95% confidence limits. If we had a perfectly normal data set, the 95% confidence, we look at that and we say that is the central part of the data set. There's going to be 2.5% in each tails. Any value that exceeds 2.9 times the grand median, the 95% confidence limits, is designated and flagged with an X. Oops, sorry. It's funny, my cursor movement doesn't work on my computer, but the mouse does. Proficiency test statistics. So one of the things, because we collect replicate data, we can get an assessment of within lab performance on that value. In other words, how precise they are. And we use this is determined using what we call a K value. It's the ratio of each lab standard deviation within that soil property within that lab standard deviation. So there you see that calculation. So basically we're looking at the standard deviation of a soil test value within a lab against what that average is for all the other participating laboratories. And at this little figure down at the bottom, it just gives you one example. This is from last fall. This is the sample cycle 55 soils. You see the lab mean, the grand median, the MAD, the 95% confidence limits, and this is the low and the high of the boundaries. Then the within lab performance K value, the within lab standard deviation, et cetera, there going across. And I mean, we try to keep these reports simple enough that you can look at them. Obviously we have, thousands of pieces of data. We do not provide you all test parameters. We only provide those parameters that you submitted for your PT testing. And the reason we do that is if we did that for all 122 test parameters, you'd be looking at a book in terms of results. So proficiency test statistics, when we go through and we look at the data then, and we've established this 95% confidence limits, we use a z-score to determine whether you have a bias or not. And that bias value is any flag condition that's greater than 2.9, and they're flagged in red. And this is an example of 5 samples, again, from last fall that was ran. And of course, in this soil sample, test code 115 EC 1 to 2. This particular lab had a minus z-score, so therefore it had a very, very high value or very low value and was flagged in red. Similarly, they had the same thing going on for the strong Bray test. Now, let's take a look at just one sample, one parameter from last fall or from last year. This is sample 2401, soil sample collected near Garriston, South Dakota. This is the Malic 3 phosphorus ICP results. We had 46 labs submit results. The pool size, because we ran 3 reps, is 132. You may say, Bob, well, no, wait a minute. 3 times 46 is not 132. Well, there was 3 labs in this data pool that did not submit triplicate data. So they're in that total N of 132. For this particular soil sample, the lowest reported value was 10.3. The highest was 251. This gets to my point how this data can be very, very skewed. A skew value of 6.5. You see there the mean is 26.9 and the median is 22.6. There you see what that effect of that value of 251 has on the arithmetic mean, but the median, because the middle, is very constant. It's 22.6. This data set had a MAD value of 2.0, resulted in confidence limits of plus or minus 5.4. You see this graphic histogram plot there at the right. You can see where the central point is. I didn't carry the graph off to the 251 part per million one because it would really make this graph, really stretch it out. But because of this, when we go back to the data, we use the z-score to flag the biased, high and low. You see one lab was be flagged at being low biased and 2 labs were flagged at far right at the high biased. You can pick out that one lab because their value is that 10.3 there. So that kind of gives you an idea of how we look at this data. Obviously we don't print graphs for every test, every method like this. I just bring this to your attention. Now, let's talk about the within lab statistic. This is something unique to ALP because we're going to be able to tell you, because you ran 3 replications, how well is your precision? And we use this K-factor test, which I've described earlier. And here is the same data for the same soil sample, the 46 labs that gave us results. And so the minimum K value, this is looking at the within lab standard deviation against the average of the national. It's a 0.01. I mean, obviously very low K factor. The max was 3.91, however. And the median was 1. The K limit value we established on this was 2. And as a result, 3 labs were flagged for poor precision. Now, remember this is a one-tailed curve because nobody gets anything less than 0. But you can see that clustering of all those labs who gave us results that had K factors less than 1. What does that mean? On this particular sample, the within lab RSD, if we calculated and showed that to you, the RSD is going to be under 4% for all those labs with a very low K factor. That lab out there with the value of 3.91 would have translated into a RSD of approximately 16%. Okay, I built this table around showing this concept so we can integrate both the interlab and the intralab performance scores here. And so this is the same sample, SRS 2401, the Malic 3 phosphorus results, and from cycle 53. And if you look at this, here is the samples ran in cycle 53 for all the 5 soils. Here's the interlab median, okay? And then here's one lab I picked out at random, 9290. Here's the mean value they gave, and you'll see there the first one's flagged in red. So the interlab median was 22.6, but they reported with lab a value of 30.7, obviously high biased, and they were flagged accordingly. But you look at their K values down there, all 5 soils, all of them are less than 1. So they had very high within lab precision. but they failed because they had high bias on the very first sample, which happened to be the lowest testing of the group. If you look at the rest of those comparisons between the interlab median and their mean, they're pretty close on almost all those samples down there. Granted, this 2402 is about a 9 part per million shift, but the rest of them are fairly close. But then I'm going to have to move this window here. Bear with me a second. Lab 7229, if you look at their values of the mean against the interlab mean, man, they nailed almost every one of those samples down the page. But note, they had 3 samples, their K factors were greater than 2, which tells us that they had a real precision problem on the 3 highest testing samples in that suite, which is really, I think, great information to say, well, if you've got a problem of precision in your lab, that's just as important to have for good quality as it is to assess your bias within your lab. So updates, and I'm going to be moving my stuff around here to accommodate my screen tab. So for ALP cycle 56, we've already got 4 of these soils packaged. These soils are going to come from Georgia, New York, Colorado, Nebraska, and Ontario. We're going to add for this year a new method, which is malate 3 phosphorus ICP, but based on a scooped volume, not a scooped mass. Penn State, North Carolina, Delaware, New Jersey, and there's one other lab in that pool, all scoop their soils on a volume. They use either a 2 gram or a 2 cc or a 2.5 cc scoop. We realize that the volume versus mass is fairly close, but there are soils that are exceptions. And so to accommodate that, we're going to move malate 3 phosphorus ICP into 2 categories. Domestic PT samples are going to be shipped the 19th of this month. We have subsequent dates for cycles 57 and 58 to occur the 3rd week of June and September. Beginning with the next cycle, 57, we're going to put a QR code on the labels of every soil jar that's going to show you the background information where these soils were collected. For cycles 57 and 58, we have a new addition. We've never done a soil from Alaska. We actually had a colleague of ours in Alaska collect the soils for us last August and ship it down. I'm still dealing with the shock of the cost, what it was to ship down 6 pails of soil from Alaska. I think the next time we do an Alaska collection, I'm going to have to drive up there. As you can see, we have multiple states across the country now involved in the next cycles. Manitoba, Montana, Washington, North Carolina, Oklahoma. Again, we go back to this point that we collect a soil from every region in the country and is included in every particular cycle. Botanical update. For cycle 56, we're going to have almond leaves, buckwheat, soybean leaves, and broccoli. New for 2025, we have purchased this sieve there that you can see. This is a really nice system. We can grind our plant materials and we can put in an 80 mesh screen. We're actually doing an assessment whether we want to go down to a 100 mesh screen. This really works well. We can put in 1 kilo or 2 of material in here in about 15 minutes. It can do a good job of sieving this. Sometimes we have to regrind because we have too much retained on the coarse sieve. And then additionally, last year we purchased this 10-liter cone blender there at the right. This really works well. We purchased this for a lime project. It's a 10-liter volume. We can put the material in there and let that run for hours. So, as many of you know, we've been discussing starting a soil carbon program. Collaborative testing services, they want to make sure that if we get into this, that we know what we're doing. In other words, we have a good plan in terms of how to do this. Now, we've been studying this for, I guess, the last 15 months about the scope of the proficiency testing program, what analyses are going to be needed to done, how much prep do we have to put into the samples, what parameters are the most important. And we've settled on this, that the soil dry matter content, the pH, the soil organic carbon content, the inorganic carbon content, total carbon, and what we call reduced organic reduced organic carbon content. This is not a term that we've used very much in the United States, but from my contacts in the EU, this is kind of a standard thing that they want to know. This is elemental carbon that's in the soil. It can be the result of charcoal, or it could be associated with some really, really reduced carbon materials that's been in anaerobic conditions. We've done a preliminary assessment with LECO and Elementar looking at the carbon analysis of those instruments. What we did, we ground our soils. We sent them to both of the manufacturers and did an assessment with them about how fine a grind do we have to do? What does it take to get a homogeneous materials? Just a note on that, in the Elementar study, we ground the soils to 4 different size fractions: 2 millimeter minus, 1 millimeter minus, 0.5 millimeter minus, and 0.18 millimeter minus. And then we did a subsampling size study to determine what was the optimum mass that has to be ran through the instruments. And these results are going to be presented in June at the 18th ISSPA meeting. We've got an oral presentation talking about the results of that study. And then our program is based on 4 PT soil materials that are submitted triannually. So it's basically going to be 3 times a year, just like our current ALP program is, but it's only going to be 4 soils for these 6 parameters. Okay. Excuse me. So the real advantage to the ALP program is cost. We are a lower cost program than our competitor. Basic soils program is only $540 a year, but there's additional cost savings because we're not 4 times a year, we're 3 times a year. So you save considerably, 25% on your PT sample cost besides the lower front end cost. Service, ALP offers retest kits through the ALTA program for certification of laboratories. We also have reference soils in our warehouse. So right now, I think we're out, we've probably got 1,800 kilos of reference soils that we have stockpiled for future sales. Sometimes we rerun these through the program. And we collaborate with ALTA on the EQA double-blind evaluations. We'll probably have an update that to the group here in about 6 to 8 weeks. We've met with all the laboratories, reviewed the 2024 results, and I'm going to send out their official reports the first part of April. Support, laboratory technical consultations, soil analysis methods, quality control. My name's on several methods manuals. I've worked in quality control for a long time, done several webinars on that. I'm not quite up on some of the newest ICP operations, but the fundamentals are still there. It's the software that's really changed in the last decade. And soil analysis interpretation. And one last thing I have to say, I know many of you have heard about this, but the 18th International Symposium is going to be in Durham, North Carolina, June 9th through 13th. I really hope you would consider coming to this conference. This is the first time it's been in the continental United States since 2009. It's got a great program. Christian Hicks, who's the past president of SPAC, and Dustin Sawyer at Rock River, who's the current president of SPAC, have put together an outstanding program. We have workshops on the first day on Monday. Tuesday, Wednesday, Thursday are oral sessions, symposiums. Last day is a tour in North Carolina, followed by a banquet. This is a unique opportunity because of both industry, university, and people from all over the world who work on soil testing, plant analysis will be there. And with that, Corey, I will finish up for questions.
That was great, Bob. Thank you very much. So I would encourage everyone, if you want to ask a question, please feel free to put it in the chat and we'll address it, or you can use you can just come off mute and Bob or I will notice and call on you and you can ask a question out loud. I will also say that I just put in the chat the registration for our next webinar, which will be March 28th, where we'll have Greg Gielan from Agilent Technologies presenting on ICP OES. And that's going to be a really great partnership with Agilent, where we're going to bring some technical training on ICP, but also of interest to agronomists and other people that want to understand how these instruments are kind of the workforce of our ag programs. So with that, do we have any questions for Bob? Bob, while the crowd kind of warms up here, I do have a question for you. One thing that at Alta we've discussed a lot is plant tissue testing and how much do labs value plant testing from a proficiency program and things like that. Can you comment on how I know ALP has a proficiency program for plants. Can you comment on how that program has developed over the years and any thoughts on that?
Yeah, thanks, Corey. Corey, your microphone's breaking up a little bit. Be close to it the next time you respond. So the ALP proficiency program initially was 3 plant samples 3 times a year. We realized that we want diversity in that program. And what I mean by that is we would like to have a row crop, a forage crop, a vegetable, and a tree crop. So that's why in 2014, we expanded the program to 4 different plant materials. And the other thing that we added also at that same time, we added heavy metals. So we have your arsenic, cadmium, nickel, barium, strontium, et cetera, in that program for heavy metals. And we were the first program to offer that within our PT scheme. Right now, we're running 66 labs. It's in the ALP proficiency testing program for bot. Sorry guys, we call these bots. Whenever we're talking about plants, we just use the word bots because they're botanicals, right? So, the thing I've really tried to push, continually improve the process. That's why we bought that power sieve there with the Hunt 80 mesh screen in it. That really works well. We also have purchased, we actually started purchasing these back in 2019. This is a Chinese made grinder. It's a rotary grinder. It runs at 25,000 RPM. I love UD mills for grinding our plant samples. They're too slow. Our Chinese grinders, I'll have to say these, they're disposable. They cost about $125 a piece. They hold a volume. You can put in about a liter and a half of plant material, and you hit the button for 15 seconds and it's ground up. So they work really nice. I'll just say this, when we look at the plant proficiency testing, because you're looking at quantitative analysis for almost all the elements, the statistics on it are a lot cleaner to work with. There's data sets are not as skewed as badly as they are in soils. And you end up with interlab RSDs often in the 1 to 3% area. I forgot to mention this when I was mentioning soil carbon. 2 things had come to my mind. One is on the soil carbon program. We were astonished that if we process our PT samples that we're planning to use with LIGO and with Elementar, we were able to obtain RSDs on repeated tests on those samples of less than 0.5% SOC carbon. So that's very impressive. And for the soil carbon program, if you have interest in it, this demonstration round is going to be free. So if you have interest in this, let me know. Come to my email, send me an email address on it. We will include you on the list. But we're going to limit this to 4 or 5 labs because it's just an idea to make sure that we have everything that we do in terms of T's crossed and I's dotted. So,
Bob, do you have your email on the slide before this?
Yes, I will do that. Let me go back. There
Yeah.
it is.
Sorry about the microphone issues there the first time around. We do have a couple questions. So first question, I know this is a topic you love to talk about specifically. Does storage of soil samples affect overall chemistry? And Bob, I want you to answer this from a short term, like 30 days to 90 days, and then also from a long term, multiple years. Thought
Okay.
because I know you have some thoughts on both of those.
Okay, so for the ALP program, gosh, I've 276 soils. I think we've reran 3 over the years, a second time. And I'll say this, I'll talk short term. As far as I'm concerned, if a laboratory processes sample, dry, grind, and run, stability on the shelf, as long as the moisture is under 3 or 4% moisture content, I think those soils are stable for probably 3 to 6 months. Caveat though, is if you're in the South and you're dealing with humidities of, 90% all the time, and the air temperatures are over, 80 degrees in your storage area consistently, probably not. But for 30 days, absolutely. Regarding long-term storage, there was a soil that we ran 2 years ago. It was collected in Canada back in 2018, I believe it was. And the thing that shocked me on it was that the only analysis, remember, we store our soils at less than 3% moisture, but they're stored in a warehouse, which means they can go from minus 20 degrees Fahrenheit, which we had here 5 weeks ago, to air temperatures of 90 degrees in the summer. That soil was reran through the PT program in 2022 or 23, excuse me. And what we noticed was almost every parameter in the page, with the exception of manganese, was exactly the same median value that we got. In fact, in the case of EC, the median was the same value to the third significant digit, which for me was astonishing. Also astonished to me there wasn't any nitrification or ammonia loss in these samples over that period of time. Now, remember, I live in Colorado. Relative humidities are relatively low, but we've done this multiple times. I think, well, we'll find out sometime. We're going to rerun a soil from 2017 here in the future, and we'll have another comparison after storage for 8 years. So.
Great response and great thoughts. I think that that's something in the ag world we question a lot is how long can we store these samples and how long. I like the term shelf stability, and I like the guidance of a few months if the humidity and temperature are right. So that was great input.
Just a second, Corey, just a note. On the manganese, I want to warn you guys, the manganese on that soil from 2022 versus 27 or 2018, the manganese went up 3x. It's very because it's redox potential. And once you dry a soil and expose that to air, the manganese is going to continually oxidize. And then one footnote, and we didn't do this in the PT program, but we have a soil sample that we ran through the PT program, and then we shared some of that soil with a particular laboratory. We found the first instance that malate 3 ICP phosphorus changes. And in the case of that soil, it was only stored for 2 years, and it went up, oh gosh, it went up 30%. Now, I think that's a rare situation because I haven't seen that before, and it might be because fertilizer history on the field. So anyway, enough on that. More questions.
No, but that highlights an important thing, which is that chemistry is complicated, and so it's a harder answer than some might expect. So next question, and this is kind of a broader question, but I'm gonna go ahead and throw it at you, Bob. How can we measure carbon sequestration in soils under the effect of tillage or subsoiling? Is there any tool? So it's a little bit different than the topic today, but I think you might have some insights on that. So.
Well, I got to tell you, I'm really apprehensive about this carbon thing because the science, the chemistry, the biology of it, boy, it really has to come together to make it work. Now, just a sidebar, I've done the back of the napkin calculation, and to increase soil organic carbon, 0.4%. If you assume that you're going to have input carbon quantities of 20 to 22,000 pounds of carbon, that's like 10 to 11 tons per acre per year, and you don't grow another crop, and you assume 15%, 85% is oxidized every year of that biomass, right? It takes 10 years. Now, the problem with the soil carbon for me, and it's not a lab issue, it's a sampling issue. We all know the variability that we have on the landscape, and getting an accurate bulk density sample to begin with. I don't know. Again, I'm very apprehensive about this, but if somebody wants us to test this and they're willing to provide, capital resources to do management, to provide, some kind of income stream for this, wonderful. I don't think the lab's the issue. In fact, I will say it's not the issue, as long as they have a very documented SOP with each one of the steps to take into account. And the processing costs for just getting the samples run on the front end. Many of you know I was in Australia last year. I spent some time in a lab down there that does about 1,200 carbon samples a day. The amount of labor that goes into processing those samples is incredible, but the numbers they're putting out of the lab are pretty high quality as well. As terms of the tillage thing, boy, that's a Pandora's box of problems. And then we come back to this, we got spatial variability. Now you throw tillage variability on top of that. So.
Yeah, I mean, I would just add that I would just build on the sampling challenge when it comes to doing any soil carbon work, and the importance of working with the lab that has experience doing field work if you're hiring that work out, because it takes specialized equipment and it takes special training for a field technician to really do to pull those samples correctly and effectively. And so that that's a special skill set. So the next question that we got was, what about soil EC 1 to 5 gives better results as compared to EC 1 to 1? Do you want to expand on that thought, or do we need to ask the questioner to add some more
I
details?
think we need more input from the questioner. I mean, anytime you dilute a sample down and measure EC, you're dealing with the fact that, you're getting into the detection limit areas. I mean, if you start off with an EC of 1 to 1 at 1.0 and you do a 1 to 5, now you're down there at 0.2, I mean, things. I used to say this, I never had much confidence in EC, but I think the technology, the probes have gotten better. And as long as it's a well-calibrated system, they do better. One complication I will tell you from past experience on EC is that those platinum electrodes inside those sensors, they'll get coated with organic matter. And if you don't do periodic cleaning on those, they can become a problem.
Any other questions? Oh, we got to think. So I think you answered that adequately, Bob. Any other questions for Bob?
Well, if any of you want to follow up with me later, send me a text, send me an email. We'll get together and talk about stuff. Like I say, we're really focused right now on getting the next round of ALP samples out. Got one more soil from Canada I got to get processed, and then everything will be ready to final package. Look forward to hearing from all of you, and also like to see you, if you're possible, can attend that meeting in North Carolina in June. It's a unique program. You get to rub elbows with a lot of both academics, but also people from outside the United States who kind of do the same thing that you do, just in a different country. So with
So
that, go
I will
ahead.
just I will just add, since we're doing an ALP update, ALP has been a long-term partner of Alta since before we were Alta, and we were just the Illinois Soil Testing Association. So we're always glad to share partner updates. And so with that, I thank everyone for joining us today. The webinar was recorded, and I'll be sharing that out for those who weren't able to attend. Otherwise, thank you very much.